Hello everyone, and welcome to the first presentation within this section. My name is Adrian Carr, and I'd just like to thank Dimitri for the introduction, and I'd like to thank the organisers for this as well, listening in to this topic too. So I shall be talking about customer journey optimization, and I guess the first question is, why is that in this section on recommendations? And there is a big overlap between recommendations and customer journeys. I think the most important thing to highlight is that recommendation systems are often trying to predict the next action for a particular customer, and will use good information to predict that. Customer journeys are also trying to choose the next action, but the key thing they are trying to do is identify whether there are events that are more predictive than the individual events themselves. So does A, B, C lead to a better result, for example, than A, C, B, or A, C, D, for example? So what we'll be doing in terms of this, I'll be first of all describing how we manage some of these journeys, secondly, how we measure them, and finally, how we make that step towards optimizing them. So just to give you an analogy of what we mean by customer journey optimization, one analogy is that it's a little bit like encouraging a customer to traverse a river towards your ultimate conversion purchase. And it's not just a purchase of a particular item, like a retail item. A purchase can be on mortgage or a loan or a credit card, or a conversion can be just spending more on a credit card, for example, or drawing down more. Those are the different things we're talking about. Now, the traditional approach here is that we understand that there are several different steps that a customer can take towards reaching that conversion goal. And one way of traditionally marketers try and get customers to do that is almost to pull them across this river. Now, the issue with more of a pull approach is that you often lose your customers midway through the journey. They fall off and they, in this example, swim back to the wrong side of the river. Now, what people are trying to do nowadays is light the way for the customer towards that conversion. And as I say, light the way, I also want to emphasize the point that what works for a particular customer. And so understanding the individual's requirements as well is really quite important here. So that's what we're talking about in terms of customer journeys. So first of all, how do we, and a lot of people, our clients included, will use business rules to manage customer journeys and almost use good insight, things like models and indicators to split journeys and create new journeys, and essentially try and identify these from a marketing perspective. And we're able to do that, and we facilitate that process of the management of those journeys. But we want to do more than that. Now, our first step in wanting to do more of that was to start measuring these journeys. And the approach we started to take towards measuring these journeys was one of attribution. We've got a conversion goal. We've got conversion that's of a certain value. We want to then attribute that value back to the various steps on a journey that occurred previously. Now, a lot of people are familiar with vision, and I have an example here where I've got 3 different traffic sources leading to a conversion. And this is what we're trying to do, attribute value from that conversion back to those different touch points. And there are several ways that already exist, and I would describe most of those as rules-based approaches. So you'll be familiar with things like first touch attribution, last touch attribution, maybe linear attribution, those kinds of models. And we were able to represent all of those models back to a user for any particular. On that point, I think it's very important to say different KPIs are important. So you may want to do attribution in terms of people just visiting your site to inquire about a loan, but you might also be more interested in people who visited your site to inquire about a credit card. And the attribution models of those two may be subtly different. And so as such, it's important to measure those differently as well. So we do give people the ability to do that. Perhaps more important is the analytical approach towards the attribution. So a rules-based approach is good, but can be biased. And typically the rules-based approaches, what they do is they share the conversion based on rules. And they don't look at non-conversion, for example. So you could have one path that has 1 million customers on it, but only 10 conversions, versus another path that has 1,000 customers on it and 100 conversions. Non-conversion rate and help or use that to help understand the attribution problem more. So we at SAS have taken an approach of using decision tree technology to uncover the paths and then use traditional logistic regression techniques to attribute the conversion share. And that approach allows us to, number one, understand the different paths that exist, and number two, as I say, attribute that share better. Now, I've got one little example here of how we are starting to see the paths that are coming through analytically. And just one example to show the conversion share here is different for paid search versus organic, then direct, versus organic, then paid, then direct. And what a marketer could now do with this is perhaps journeys to represent these paths that are leading to higher or lower conversion rates. And perhaps they could also identify opportunities for points of intervention. Now, I wanted to mention was it's not just about digital traffic sources. One also needs to take into account the events and the actions that you take on your website. And this is a good example here as regards how we're starting to bring in these additional events to help marketers understand those journeys that bit better. How we're using the same techniques in the background to pull these through. So let's now talk about optimizing that next step. You know, we've got a good idea of how we can actually manage the journeys. We can have a backward-looking approach towards the attribution, and we can use that in a predictive manner as well. But what we really want to do is this. We want to optimize what we do next for that path. And using the diagram from before, here is that magic optimization button. And let's describe what that needs to do and how it needs to do it. So the first thing to mention is the algorithmic approach we're taking here. And we've chosen to use recurrent neural networks themselves well to the customer journey optimization challenge. And that's because journeys can essentially be considered to be states. So a state is a combination of previous events that have occurred. In addition, and I want to emphasize this point, that state can also represent some demographics or even some models so that you help the model learn more quickly. For example, you may be able to identify borrowing customers or credit customers better than savings customers and just help the recurrent neural network learn quicker by giving that business insight to it. But to summarize what a recurrent neural network does, there is a state that a customer is in, there is an action that you as a business take, and then you observe what the benefit or the reward is from that action. And then that feeds back into the neural network to improve and enhance those decisions. And so the process here also relies on something called Q-learning. Q-learning is a good way of essentially measuring what the reward is, and it also takes into account the cost of that particular action as well. And so in terms of doing this, the other important thing is exploring and understanding all the different journeys that are there. But the first step one takes when one is doing the journey optimization is identifying what is the best action to do for that customer. And so this assumes we've already been running this algorithm for a little while, and we know what the value of each of the different actions are for each state. And I'll come on to how we can assess that in the next few minutes. Chosen the action that has the best Q value, essentially. When we've chosen that, we then recognize and understand what reward we actually get from that action. And here's the very important thing that we then do. We then pass that reward not just to that state that the customer is in now, but the previous states it was in before. And so passing that back through a discounting way enables us to update the matrix and update the values so we can make much better decisions going forward. Now, an important part of this as well is around this exploration versus exploitation phase. And in simple terms, this is simply saying you don't always choose the best action because you want to make sure the worst actions really are still the worst actions. But another way of thinking about this is that if you have new actions becoming available, how do you assess those new actions? Exploitation and exploration will allow you to test those new actions to make sure that you are staying optimal. And in a world which is changing, and with customers that are changing as well, I think that's quite important. And whilst I'm on that topic of the way here is that whilst we are only having a matrix that is a combination of states and actions, the customer will actually move between states. And their journey as they move between those states is essentially representing the customer journey. Good. The journeys, and as the customer transitions between states, that's essentially representing the journey that they take. We choose the best value based on not just the next step, but the future steps behind that as well, or in future of that as well. We keep it fresh by having the epsilon greedy approach to exploiting versus exploration. And ultimately, we're making better decisions. So, one of the challenges here is that the state space is huge. So if you think about all the different combinations of different things that can be occurring, I think I've lost. Am I lost? One of the challenges we have here is scaling to large spaces. So hopefully you recognize that the number of combinations can be huge. And so it's not feasible to simply apply the actual reward values and discount those actual values. It's not possible to test all of the state space and all the actions to evaluate those. So actually what one has to do is one has to predict those values. And you could have a simple model. The approach we've taken to this is to have a deep neural network to understand that. And so I think that tends to work better than some other approaches. Okay. What I'd like to do, so I think I've described the fact that we use neural networks for that deep reinforcement learning to predict those Q values. So that enables us to really manage that well. And this is customer demographics in the neural network to help predict those values a little bit better than without those. The neural network technique that we're using here is a long short-term memory network. What that means is sometimes you have purchases which have very important considerations. So let's use a purchase of a loan here, is that you can have somebody checking a pricing calculator. They can also check perhaps income and expenditure. But they might do that a month before they actually purchase the loan. So what you need to do is you need to keep some of those significant events that can happen in a short period of time, but a long time ago, and make sure that those are still helping you predict going forward. And this slide hopefully gives you a little bit of an idea as regards that one. So how does this work in practice? The key thing I wanted to say was that evaluation of deep reinforcement learning and using our customer journey optimization algorithm is that it really does start to pick up on signals. So what we've done is we've got some examples where perhaps we've got actions across 3 different points. And what we do is we hide a signal in the data. So for example, for people over 40, ABC is the only combination that will work. For people under 40, maybe BAC is the combination that will work. And what we've identified is that our algorithm is able to find these signals and then optimize those signals or optimize those actions so that we are optimizing the customer journey. And this works over and above traditional techniques of things like A/B testing. It will work over and above a traditional recommendation system as well, which might just simply be able to find the best action for the best customer. Having said that, there are some combination techniques one could use in recommendation systems. So I think it's fair to say that we've used those techniques. We believe that on dummy data, this works really, really well. I think the challenge now in the industry, and I think this has been in the industry for a while, is do these sequences exist and where do they exist? And so we're now in the process where we're very keen to test this in more live environments to try and find those signals. So I think it's fair to say this is cutting edge. Not many people are doing this. If anyone out there would like to know more about this, please feel free to get in touch with me or our team in Russia, and we could explore how we could perhaps help in your business. And I think I'm still talking, I think I'm still live, but if I'm not still live, I'm quite happy to hand back or take questions.
Thank you for the thoughts you've shared. And we have a couple of questions here. We all live in the new reality affected by pandemic. Can we expect that recent trends in e-commerce somehow affect how recommendation systems evolve? And
yes,
can AI become the key for optimization of customer relationship and customer journey?
Yes, so I think that's a good question. And the simple answer is yes. To make more clear, though, is that the customer journey approach with this exploration versus exploitation is almost a system which would have naturally reacted to the COVID-19 emergency without having to have any external effort to change it. Because what it would be doing is it'd be working out which actions, which events, which channels, for example, are working better now. And by testing the things that are not working as well, it will learn that those start to work better in COVID circumstances, and it will kind of like pass back that reward. So I think something like the recurrent neural network where the states but the values differ, it's that differing in values over time that will then naturally evolve towards people having different actions chosen about them. So it perfectly correlates to both the CRM system and a world of constant change.
And what do you think? Is it possible that someday AI would completely replace eliminate human from the marketing decisioning process?
No. Again, no is the straight answer. I've done a bit of research on this, and we do a lot of work in terms of both our work with clients and our work developing products, and nobody really wants a pure black box. Even if they want a black box, they want to be able to have some features and some knobs that they can twist and turn to customize it. And here's the thing as well, I gave the example that by introducing some business knowledge, you can help these systems learn much, much quicker. So I never think we will lose humans, not in my lifetime anyway. And I'm hoping to have a long life. So there we go.